Okay, so this is the last practice problem that I gave you guys right before you left. There's no calculator for this, and the first question is to find the area of region R. So each of these little sections is made up of a rectangle with a width and a height that is the upper function minus the lower function, which is square root of x minus x over 2. And so we're going to take the integral from 0 to 4 of square root of x minus x over 2 dx. And we have to evaluate this by hand. So we have, it's the same thing as the integral from 0 to 4 of x to the 1/2 minus x over 2 dx. And the antiderivative of x to the 1/2 equals 2/3 x to the 3/2 minus x squared over 4 from 0 to 4. So we're going to plug in 4 and you get 2/3 times 4 to the 3/2 minus 16 over 4. And when you do 4 to the 3/2, you should square root first. That gives you 2. 2 cubed is 8. So we have 8 times 2, which is 16 over 3, minus 4, which is a total of 4/3 area. Okay, so for part B, we are finding that the region R is the base of a solid. For the solid, the cross-sections perpendicular to the x-axis are squares. Find the volume of the solid. So each of these little segments is the base of a square. So here's my square over here. And the base of that square is the upper function minus the lower function. So square root of x minus x over 2. And we are squaring that to find the area of the square. Which we're actually going to have to FOIL out by hand because this is no calculator. So square root of x times square root of x is x, minus x square root of x over 2, minus x square root of x over 2, plus x squared over 4. And you end up with x minus x to the 3/2. These two combine to x square root of x divided by 2. The 2's cancel. And you're left with x square root of x, which ends up being x to the 3/2, plus x squared over 4. So that's the area of each square. And now we're going to find the volume by integrating the area, or thinking of it as a rectangular prism. So the volume is the integral from 0 to 4 of x minus x to the 3/2 plus x squared over 4 dx. And when we do the antiderivative, we end up with 1/2 x squared minus 2/5 x to the 5/2 plus x cubed over 12 from 0 to 4. So plugging in 4, we end up with 1/2 times 4 squared minus 2/5 times 4 to the 5/2 plus 4 cubed over 12. So at this point we're going to simplify a little bit, and we get 8 minus 64 fifths. To get that, I did the square root of 4, which is 2, to the 5th power is 32, times 2 is 64, plus 64 over 12. And so from there, we need to make a common denominator. My common denominator is going to be 60. So I have 480 over 60 minus, and then to do 12 times 64, I did 64 times 10 plus 64 times 2, so 640 is 128, and that's 768 over 60 plus, and then we're doing 64 times 5, which is 320. And so we get a positive 800 over 60 minus 768 over 60, which is 32 over 60. I'll leave it like that. And then for part C, write but do not evaluate an integral expression for the volume of the solid generated when r is rotated around the horizontal line y equals 2. So y equals 2 is up here, and if I rotate it, it's going to come out with another cross-section up here. And we're talking about a solid that has a hole in the middle. So we need the volume of the large cylinder. So that radius is from here to here. And then we need a volume of a small cylinder whose radius is from here to here. So the volume of the large cylinder is going to be pi r squared h, which is pi. The radius is from 2 back to x over 2 squared. The h is dx. The volume of the small cylinder is pi. The radius is 2 minus square root of x squared dx. So to calculate the volume total, we can write it as pi, the integral from 0 to 4 of 2 minus x over 2 squared minus 2 minus square root of x squared dx. And that's all we had to do for that problem.